Welcome to the EasyScleral Fitting Guide. This guide will introduce you to the principles behind EasyScleral lenses, insertion, removal, fitting and some aftercare. EasyScleral lenses have typically been reserved for the most irregular corneal conditions that we face. But because they're a very comfortable lens to wear and because they can prevent centration issues and fitting issues that we have with other types of contact lenses, they're becoming increasingly popular for even mild to moderate corneal irregularity. Because there's a captive tear layer between the cornea and the contact lens, they can be a useful lens for conditions where there's ocular surface disorders. EasyScleral lenses are made on the most advanced manufacturing techniques available in the contact lens industry. This free-form or polish-free manufacture means that the lens quality and repeatability is guaranteed from one lens to the next. This means that making adjustments to the lens is going to be adjusted accurately, and this keeps also the delivery time and the cost of the lenses down. So the geometry of the contact lens is supplied either in a 16mm or an 18mm diameter. 16mm is better for less irregular corneas where there's less ectasia. 18mm will be needed on more extreme forms of corneal ectasia. The lens fits the eye on the sclera, and this can be adjusted as the scleral angle, either standard or plus or minus, and these can be increased or decreased in 4-step changes. The corneal sag allows us to alter the area vaulting the cornea, and this is fitted dependent on the extent of the corneal ectasia. We can also alter the limbal clearance, so the peripheral cornea. If the peripheral cornea is very steep, then we can increase the limbal clearance. If it was very flat, then we can reduce the limbal clearance. These measurements are all taken from the slit lamp, which we'll cover later on. So you can see from a fitting set lens, we get a very variable lens design that allows us to fit pretty much any cornea that we come into contact with. The parameter range of the lenses is very large. Not only do we have the two diameters, you have 16mm or 18mm, we can adjust the corneal sag, the powers, the scleral angle and the limbal clearance. The central thickness of the lenses is 300 microns. This provides us with a dK/T of 33, making the lenses suitable for daily wear. The material supplied in is Boston XO, providing stability, quality, breathability and longevity of the lens throughout the life of its use. These fitting parameters are all available in one fitting set consisting of 21 lenses that should allow us to fit most of the irregular corneas that we encounter. The corneas vary significantly in sag depending on the condition that we deal with. So we don't rely on curvature with these lenses that we would do associated with corneal lenses. You can see here from normal eye conditions and keratoconus right through to keratoglobus, the sagittal depth of the corneas varies immensely within each condition. So where do we start? Well, a good fitting point or a good starting point for the fitting set would be to use the 2100 lens and pick one diameter that you think is going to be suitable for your eye, either 16mm or 18mm. Changing the diameter after you've established a reasonably good fit can alter the fit, so you might need to restart the fitting process. So try and select the appropriate diameter first. So once we've selected a lens, we need to insert it. This is simply done by us filling the lens with preservative-free saline. The lens can either be held on the fingertip or it can be placed onto a contact lens sucker. We then want to instill a small amount of fluorescein into the saline that fills the lens, and then we're going to place the lens on the eye. So to place the lens on the eye, just get your patient to look down about 45 degrees, hold the lids out of the way, place the lens into the lower sulcus and straight onto the eye, covering the cornea, and then just mop up any excess saline with some tissue paper. Watching the same thing using your fingertips. Fingertips obscure the view slightly, but the principle is exactly the same. And whether you use a sucker or your fingertips is down to personal preference. Once we've got the lens inserted, we want to make sure that the fit isn't either excessively flat where there's corneal contact or that we don't have a bubble trapped under the contact lens. This can be done with a blue torch. A quick assessment will give us an indication as to whether we can then get the patient to the slit lamp and perform a more thorough assessment. If we need to remove the lenses are easiest to remove with a solid contact lens sucker. Hold the lids out of the way just as you did for insertion. Place the sucker on the lens at about the 6 o'clock position, and the lens should just easily remove from the eye. So scleral lenses are assessed from the outside in the way, rather than a corneal lens where we tend to start in the middle. So once we've established that we've got a lens that we can assess, we're going to start by assessing the scleral part of the lens, which is from about 14 millimeters out. The corneal area should be completely vaulted and should just glow green with fluorescein. Ideally, we want there to be scleral alignment all the way around the contact lens. This is best assessed with low magnification white light. You want to get the patient to look straight ahead, but also to the extremes of gaze. And we can tolerate small areas of sectoral blanching. So here's the video showing a scleral assessment. Again, with white light, we get the patient to look, and we're looking for the blood vessels to see that they track underneath the edge of the contact lens without being cut off. In this video, there's very mild nasal blanching. Now, the nasal sclera is the flattest area of sclera on average, so sometimes we can get mild blanching. If the eye doesn't become hyperemic and irritated with wear, then the chances are we've got a suitable scleral fit. In cases where we have a flat scleral fit, the patient will often have some lens awareness. They'll be aware that the edge of the lens is lifting away from the eye, and their lid picks up on that. But we also see blanching of the scleral vessels away from the lens edge towards the lens center, as is shown in the photograph. If we saw this, we want to select a scleral angle 1 step steeper, insert the lens and reassess. If we see steep scleral angles, then we see blanching at the very edge of the contact lens. Again, the eye becomes hyperemic. The patient generally will have, the lens comfort will be okay to start with. Patients will often describe the lens as starting to sting with a bit of wear. And again, you'd want to select a flatter scleral angle by 1 step and then reinsert and assess that. If you've selected the 16mm, and we've got a more extreme corneal ectasia, sometimes the increased bearing, the weight of the lens effectively pushing down on the very narrow fitting area of the 16mm can cause blanching of the blood vessels. So you'll see that the scleral angle is actually parallel to the eye, but blanching is still occurring. In this case, you would want to select the 18mm. This will spread the area and the weight of the lens over a bigger area, so you shouldn't experience blanching. So if we see a flat scleral fit, we're going to select a scleral angle 1 step steeper. And if we see a steep scleral fit, we're going to assess 1 step flatter until we have an optimum fit all the way around the lens periphery. Once we've established the scleral angle, we're then going to go on to assess the corneal clearance. The methods we'll use for this is checking the corneal clearance with just a general blue cobalt light. And then we're going to use a cross-section view with the slit lamp to measure the actual amount of corneal clearance that we have. So to assess this, we want to bring our viewing system round to about 45 degrees, have a bright section, narrow section view so we can assess the cornea, the tear lens and the contact lens. So here we can see that the tear lens and the contact lens are about the same thickness. Now the contact lenses are supplied at 300 microns thick, so in this image we can see that the tear lens is also 300 microns thick. And this is the optimum amount of apical clearance that we want to achieve. With the cobalt blue view, we can see that there's no area of the cornea that's higher and no area of the cornea is being touched. So this is an optimum starting fit. So we want to have 300 microns of corneal clearance after insertion. You can sometimes get small amounts of variation once the lens is settled, but a settled clearance needs to be between 200 and 600 microns. So there's quite a large area of error that we can have whilst we're still achieving a successful fit. The most important thing is we don't have any areas of corneal touch. In this image we can see that we have got apical touch, so this is an inappropriate fit. We want to increase the amount of corneal clearance, insert a new lens and reinsert. In this case, the green fluorescein image, it looks okay. We can't really see the thickness of the tear layer, But the insert with the cross-section view, we can see that we've got an excessively thick tear lens. This tear lens is probably well over a millimetre. So this patient may have problems inserting the lens without a bubble, but also the lens is protruding too much from the eye, so it's liable to be affected by the lids, and there's no need to have a tear volume this large. So we'd want to reduce the corneal clearance and reinsert a shallower lens. So again, if we have any apical touch or we have apical clearance less than 200 microns, we'd want to increase the corneal clearance of the lens, insert the new lens and assess. If we have excessive clearance, we'd want to reduce the corneal clearance. We can adjust the limbal clearance of the lenses. This is generally only required where patients have unusual peripheral corneas. So in this case, we've got a patient who has PRK, so their peripheral cornea is very, very steep. This results in contact between the lens and the peripheral cornea. So in the fitting set, we have some lenses that have increased limbal clearance by 400 microns. So one of those lenses would be inserted, and that would allow us to provide a good fit without any peripheral corneal contact. We sometimes also need to increase the limbal clearance in graft patients. This is a lamellar keratoplasty patient where the periphery of the graft is sitting quite proud of the cornea. And by increasing the corneal clearance, you can see the image on the lower left, there's some contact on the graft at the sort of 11 o'clock point, whereas increasing the limbal clearance has given us clearance over the whole cornea. This patient has a very pointed cornea, a very conic cornea, and they were experiencing a recurrent bubble whilst they inserted the lens, as is shown in the left image. We actually reduced the limbal clearance with this patient, and it meant that they could insert the lens a bit easier. The optical principles behind scleral lenses: if we have a regular eye, the rays of light focus onto the retina, sometimes without a contact lens or spectacle lens, and sometimes with. With irregular corneas, we get scattering of these rays of light. When we place a scleral lens on the eye, the lens has to center reasonably well because it's fitting over such a large area, and the tear lens regularizes some of the rays of light as they go through, so we should end up with a reasonably good focal cone of light and a clear image for the patient. This isn't always the case, because if we're dealing with the most irregular corneas that we see, sometimes the refractive index difference between the saline and the cornea is still too much that the patients get some irregularity. So you may encounter patients where they need to have an over-refraction with spectacles over the top of their lens, or you want to try and fit them with a different mode of contact lens to try and improve their vision. So the specifications that we need for the lenses, if we're dealing with a standard lens, all we need to have is the corneal sag, the diameter, and the power that's required. If you've got a more complex lens, then we need to have the corneal sag, any adjustment to the limbal clearance, still the diameter, and any adjustment to the scleral angle and the power that's required. The care products that are recommended: we recommend EverClean as the storage and cleaning solution. Using surfactant cleaners like Boston, because the lenses are larger, it tends to damage the surface of the contact lens. This then leads to premature dryness and reduces the lifetime of the lens. So EverClean helps to maintain good quality surface throughout the lifetime of the lens. An insertion should be performed with preservative-free saline. We have some unusual aftercare issues that we don't see with normal contact lenses. Of course, all contact lenses suffer from dryness, and scleral lenses are not a fix for that. The outside surface of the contact lens can still dry. If this results in poor quality of vision or discomfort from the patient, you need to manage their dry eye in the same way that we would do normally. If patients are experiencing a persistent trapped bubble, this is usually down to poor insertion and removal technique, so you'd want to recoach that, make sure they were doing it optimally. It may also be because the tear thickness that we have is too large, so you may want to reduce the corneal clearance to prevent this happening. An uncommon problem, but it can occur, is we can get buildup of tear film debris going over the visual axis. Increasing the corneal clearance of the lens will reduce this, as the tear debris will fall away from the visual axis. Patients may also need to refresh the lenses during the day, and this is generally an advisable procedure to do. We shouldn't obviously have any corneal contact. The lenses should be sitting a few hundred microns away from the cornea, so if we see any corneal contact between the contact lens showing up as staining on the eye at the mid-office, you need to increase the corneal clearance. If we have a poor scleral fit, the eye will become hyperemic and irritated, and we need to select a different scleral fit that's going to be more appropriate for the patient and ensure that we get a patient that tolerates the lens fit. Conjunctival hooding, well, this is caused by a prolapsed conjunctiva being drawn underneath the contact lens. Generally asymptomatic for the patient, although they might be aware of the cosmetic appearance. And unless we're seeing corneal neovascularization, there's no action needs to be done with this. It can't be improved really by altering the fit of the contact lens. This is just something that happens with certain patients, particularly older patients. Fenestrating the lens is not a good idea, as the conjunctiva can actually get drawn through the fenestration and cause more discomfort for the patient. A diffuse staining over the cornea. This is a solution toxicity, so we need to change the solution that the patient's inserting the lens with. You shouldn't experience this with preservative-free saline, and that's why it's preservative-free saline that's advised for lens insertion. So thanks for watching the EasyScleral Fitting Guide. If you'd like to find out more information or information about other lenses, go to www.scotlens.com. Thanks for watching.